and van mesh stresses. Okay, on mesh or van mesh also it is called as. So it is giving idea about the three-dimensional stress. Now, graphically, it has been shown that in three direction, if you are going to apply force, if suppose sigma 1 is in x direction, sigma 2 is in y direction, sigma 3 is in z direction. Okay, so what it gives us combination of average stresses which we are going to apply in x direction, y direction, and z direction, as well as the stress which is generated in x, y, z direction if you are going to subtract that average stress. What it means? It means that any component or any material has its own strength, and that strength can be considered as a its sustainable value of energy which can be sustained into that, or energy which is there in that component, and that part is going to get fail when that energy is destroyed, when that energy is released from that component. For example, if you are going to break a simple stick of wood, what it happens? You are going to release that energy to the atmosphere by means of cracking that stick. Initially, that single piece of stick is able to sustain that energy, able to what we can grasp that energy. But if you are going to break it, it means that that energy is destroyed. Its capacity is destroyed, and hence the failure is going to occur. So this type of consideration is done in case of this Wien mass stress or maximum distortion energy theory. According to this theory, failure or yielding occurs at a point in a member when the distortion strain energy. The strain energy word is very important because energy which is sustained is sustaining by means of strain only. It is not sustained by the stress. Stress is calculated value, and that is calculated by means of either force divided by area, or you are going to calculate it by means of stress divided by strain is equal to Young's modulus. So Young's modulus, if you are knowing, then you are able to calculate the stress. Young's modulus multiplied by strain. That is not case for the strain. Let me clear you. Please take your time for understanding. What happens to the strain? Strain can be measured like strain is nothing but change in dimension divided by original dimensions. Now, can you measure change in dimensions? Suppose we have applied force in x direction and it has extended by 10 millimeter. Initially that rod is of 10 millimeter and it has extended by 2 millimeter suppose. Okay, so change in length is 2 millimeter divided by original length is 10 millimeter. So change which you have measured, that is not case for the stress. Stress we are not going to measure it. Okay, strain can be measured. So the energy which is sustained, that's sustained in the form of strain energy, because strain is going to give us the property which you are going to call it as a energy can be stored in that. Like I have taken example of spring or rubber, in which if you are going to apply tensile load or if you are going to stretch it, then that energy is stored, and if you are going to release it, that energy gets released. That's why it is a strain energy, and that strain energy, if it gets distorted or this strain energy is break, then we are going to call that the part is going to get failed. So it may be shear strain energy, it may be tensile stress energy, strain energy. Okay, per unit volume of the biaxial stress system. Per unit volume means it is volumetric strain we are going to measure. This is applied for the three-dimensional, that's why it is volumetric formulae. Okay, and if they are reaching to its limiting value, then that distortion is going to take place, failure is going to take place. Now just we can remind this formulae, that is sigma average is equal to sigma 1 plus sigma 2 divided plus sigma 3 divided by 3. Average we have taken for the principal stresses in x, y, and z direction. And this value is calculated or used for calculating total strain energy. This total strain energy is UV, that is volumetric, plus dimensional. Okay, so this value is calculated, and this is the total strain energy. This total strain energy, if it is getting exceed than its limit, then we are going to get that failure is going to occur. So in detail, we'll see this theory to the next lecture. Just we were having time, and that point has to be discussed. That's why I discussed. So let me take present first. Before that, do you have any question? Anybody? You can write that question in dialog box, or you can unmute yourself and you can ask. Hello?
No, sir, no doubt.
No doubt? Okay, no problem. So next lecture, we'll see remaining two theories, and we'll finish this theories of failure. And we'll start actual designing for the static load, design of component for the static load. Okay.